Chapter 4, Exercise 2. Hints. Use Theorem 4.2 and Theorem 4.6. For a counterexample, consider a function here with a horizontal asymptote. Solution. We start from a useful characterization of a closure. Auxiliary statement. A point x and x belongs to a closure E bar if and only if, for every epsilon greater than 0, this, where this, is a neighborhood of x. Assume that this, where E prime is the set of limit points of E, definition 218b. If x is in E, then this. If x not in E, then x in E prime. By definition of a limit point, this contains a point p not equal to x. In any case, this. Conversely, assume that for every epsilon greater than 0, this. If x in E subset of E bar, then there is nothing to prove. Let x not an element of E. For every epsilon greater than 0, the intersection here contains a point P in E. Necessarily, P does not equal x. It follows that x element of E prime subset E bar, in any case, x element of E bar. The statement is proved. Now we prove that this. Let x element of E bar and epsilon greater than 0 be arbitrary. By definition 4.5, there exists delta greater than 0 such that for all p and x with this, we have this. Since x in E bar, there exists a point here. Since this, we deduce that this. A point f of p belongs to f of E. So, this. From the auxiliary statement, it follows that f of x element of bar of f of E. We have proved the inclusion here. Finally, we show that f of E bar can be a proper subset of bar of f of E. Consider a continuous function here defined as this. Let E equal this. Note that E is a closed subset of R. We have this, on the other hand, that. So f of E bar is a proper subset of bar of f of E. The graph of f. Comments. It is instructive to compare auxiliary statement with definition 218. The closure E bar consists of limit points of E and of isolated points of E. The image of a closed set under continuous mapping may not be closed. In contrast, inverse images of closed sets under continuous mappings are closed. Corollary of Theorem 4.8. In the example, we provide this, but that. Note that one element of f of R. Provided example shows that the image of an open set under continuous mapping may not be open. Indeed, the set G equals -3, -2 exclusive is open, while its image f of G equals 1 not inclusive, 2 inclusive is not. In contrast, inverse images of open sets under continuous mappings are open. Theorem 4.8. Thanks for watching.